Our alarm system is one that has a light on the front of the locker. Inside of the locker, we have created a circuit that connects the light bulb to the battery and from the battery to the push button. The battery is placed in the bottom of the locker where the wire is taped to the sides, back there. When the locker is closed, the light will shut off. As such, when the locker is open, the light is on. We have also placed a piece of cardboard in the door of the locker and in the side that forces the push button, that is right here, to be pushed, and that is when the light turns off when the door is completely shut. Our locker design works because we have our light bulb sticking out of the locker door that connects to the battery inside of the locker and a push button inside of the locker door. When the locker is open and the push button is not pressed, the light is on. When the locker door closes and the push button is pressed as such, the light is off. Once the locker door closes, the push button presses against this piece of cardboard we have in here, and the light turns off. A couple challenges we faced throughout this experiment is not only the monetary limitations, but also the supplies that we have access to. We can only spend $1 a week on batteries. In this case, we have placed a security device on multiple lockers, which would also be an issue moving forward because who would put those in the lockers? A couple questions we had throughout the process is how is the energy moved from the battery to the bottom or to the button to the light in the circuit? How does the placement of the wires on each of the items, the battery, the button, and the light affect the function of the system, and how can we utilize space better to make room for books in our locker?